Hi Dilip. I have already shared the PPT with the institute, so they will share you. I'm not supposed to share actually. It is as per the protocol, they have to share the material actually. Okay. I can't deviate the practice. It is fallen since very long. I've given already, and I'll ensure that uh, you will get those PPTs today itself. Yeah. Thanks. Okay, let's get into the topic. Yeah, we were discussing about the controls in between. We lost the time. So again, we'll start from here. Okay, controls. Controls means what? Basically, there are the systems are in place to manage the unwanted events or unintended events or situations to maintain the safety controls or safety systems in proper working order. So here the thing is, so for the distillation, as I gave an example of the petrochemical, the distillation activity operations needs a trip and also alarm devices to stop the heating as soon as cooling stops. So cooling stops in the sense, if the cooling circuit or the cooling system, if it is not inactive, so immediately the alarm should activate and inform the specific equipment operator or distillation operator so that he will act accordingly to avoid accidents. In addition, the vessel should be a safety valves to the discharge and any accidental pressure in centrifuging, blending, grinding, crushing, pulverizing, and also the sieving of flammable or explosive substances, inert blanketing. Once again. Just a minute, please. Yeah. Blanketing, earthing, and also avoidance of source of ignitions are essential. Apart from this, what other controls we need in case we are doing any reactions with the flammable liquids or substances, the inert blanketing, and also earthing and also avoidance of source of ignitions. It is also very important while handling with those kind of chemicals. Then where stirring and heating both are going on, the stirrer failure alarm and also the device to cut the heat source all also necessary. So it is a stirring is happening. In those conditions also, we should have a control stating that in case of stirrer stops automatically, the heating also should stop. Such kind of control should be there in place. Then other process and operations, apart from that other activities, you have absorption of gases. These are the other such processes we can see. The solution of the gases, liquids, or absorption of the gases by solids through whole body, or it is a penetration or consumption or substance of other scrubbing systems. And adsorption, it is an adherence of substances on surface, the substance that absorb the absorbent. And also that is absorbed in the absorbate. It is relatively as slow penetration also the consumption of gas or liquid particles through the surface of other substances, mostly a solid or liquid. It is used to remove colors and also odor or water vapors through the activated carbon and also activated alumina, silica gel, etc. And bromination, this is also one of the process where we use the reaction in which one or more bromine atoms are substituted for the hydrogen atoms in an organic molecule. And catalysis and also the catalyst, where you use an alteration of the rate of chemical reaction by the introduction of substances that remains unchanged at the end of the reaction. And small quantities of catalyst are usually sufficient to bring the action about the increase in the rate of substitutability. So here what will happen? Will increase the reaction rate by adding the catalyst, but it is not involved in the uh, chemical or chemical reaction. Sorry, it will only increase the rate of reaction. It will speed up the process. I mean to say that it is like act as a booster to the reaction. It will increase the speed of the process. Then chain reaction, any self-sustaining molecular or any nuclear reaction or products of which contribute to the propagation or reaction. Then decomposition, it is about the breaking up of chemical components under various influences by the chemical action, by the heat or any electric current or biological agents or biodegradation. And distillation, the process of converting liquids to the vapors. This is the most common process used in all petrochemical as well as some of the other industries also to extract the materials from the raw liquids. Condensation, the vapor, and also collecting liquid or distill and used for the separating mixture of liquids and also the different boiling points for separating a pure liquid from a non-volatile constituent. And electrostatic precipitation, it is widely used method for collecting the pollution of the air. It is used for in the ducts to collect the dust particles from the exhaust, the gas containing solid or liquid particles suspended, and also the particles are attracted to the deposited upon the positive electrodes. Then endothermic process, a process of combining of absorption of the heat. It is exothermic and endothermic. And evaporation is nothing but the conversion of liquid to the vapors and without necessarily reaching to the boiling points. So this is also one of the activity. When evaporation starts, whenever the liquid reaches its boiling point, it starts evaporating. But in such cases, certain conditions, without reaching that also, they will do this evaporation process. Then exothermic process, a process in which the energy in the form of heat is released. And extraction, the process of separating a desired constituent from a mixture of by means of selective solubility in the appropriate solvent, and also used to describe any process by which a pure metal is obtained from one. This is extraction. Extraction is nothing but segregating a mix of materials or selectively. For example, if it like I can say petrol also the example. If you say in extraction, the word extraction I use apart from distillation. So what we are extracting from the crude oil, we are extracting petrol, diesel, kerosene, tar, and other petroleum coke, etc. from the crude oil. And fermentation, this is also one of the process where the chemical change or brought about in organic substances by living organism like yeast, bacteria. Fermentation is nothing but how we do our traditional practice to prepare a curd. That is also one of the fermentation process. And a fractionation column, a long vertical column containing the rings and the pleats, bubble caps that is attached to the still the result of internal reflux or gradual separation takes place in between the high and low boiling fractions. It is about the controlling the flow of the liquid. Then freezing, the change from state of liquid to solids. It is nothing but freezing of the chemicals from liquids to convert into solids. Then fumigation and the destruction of the bacteria, insects, and also other pests by exposure to the poisonous gas. So in COVID, we have done so much fumigation in our facilities to control this bacteria, virus, etc. Then hydrogenation, subjecting to the chemicals action of the causing to combine with the hydrogen, and leaching, washing out a soluble constituents, then neutralization, the addition of acid to the alkali, or vice versa, still neither is in the excess or the solution is neutral. Neutralization is nothing but, as I take an example, reducing the concentration of the chemicals in the solution. Okay, that is about the various other processes we should know. Then exothermic reactions. If we talk about very detail about exothermic reaction, if the heat is given out of the reaction proceeds and this release of heat rises, the temperature of the reaction means approximately over 10-degree rise in temperature, the reaction rate doubles. So whenever the temperature of the reaction, in the sense the temperature of the chemical increases 10 degrees, what will happen? Then the reaction rate, it doubles. Thus this reaction is temperature, reaction proceeds faster and also still more heat is given out, and this chain of operation makes the reaction uncontrollable unless adequate arrangements for moving or removing the heat or pressure are provided in the reaction vessel. And the reaction rate has been gradually increased so that the reaction does not reach to runaway stage. Here we should have proper controls in place, removing of the heat or pressure in the vessels so that what will happen? We can avoid the runaway in the sense uncontrollable reaction. The examples of exothermic reaction are nitration, halogenation, amination, alkylation, oxidation, etc., etc. These are the few examples for how and in which kind of reactions the exothermic reaction happens. Now, the whether such a reaction should be regularly tested by the competent persons. So, if you see in pharmaceutical industries where they go for the testing of all these vessels in the gas line, the reactors also, they will see the lining of the glass line which is there. Basically, they use for acidic kind of reactions, and also assess they'll see for any pitting or any cracks inside the vessel and also wear and tear. And for highly exothermic reactions, since the temperature has been increased very gradually, automatic programs are provided which maintain the predetermined rate of rise in temperature, and thus they prevent the reaction from reaching runaway. In addition to a safety valve, a rupture disc with the drowning, dump surge vessels is provided to receive the entire reaction mass in case of any over pressure and also bursting of the rupture disc. And the pressure gauge, temperature gauge, and the high pressure temperature alarm, heat source or cutoff devices, quenching or process killing devices, safety valve, rupture disc, drowning tank cooling devices, agitator, feed controls and process controls, drain vessel should be regularly checked and properly maintained, and the alternative water, power, and also pumps are required to maintain the necessary cooling systems. So these are the various controls. One is a pressure gauge, temperature gauges, high pressure temperature alarm systems, and also quenching process, safety valves, a rupture disc, drowning tanks or cooling devices, agitator, feed controls, and also the drain valves. These are the various controls should be in place for these kind of exothermic the reaction vessels. The pressure and vacuum reactions. So if you see any vessel maintained at the pressure above the 1 atmosphere is the pressure vessel. So any vessel which is working above the atmosphere pressure, those are called under pressure vessels. A suitable means of pressure release such as safety valve or any rupture disc should be provided, and the gases released from the safety valve, if the poisonants, should be scrubbed before venting to the atmosphere, and flammable gases should be safely contained and cooled, and emphasis should be laid onto the proper design, maintenance and testing of the pressure vessels, and their thickness should be periodically checked for corrosion or pitting. So if you see a rupture disc, it is also one of the safety device which is used So it is a, I mean, circular in shape. I don't know, I'm not able to. It is circular in shape. It will open one side actually. It is one side direction flow. So this is how it is connected in between the pipelines. This side also you have a pipeline. It is like also act as a safety relief valve. The flow is this way. So once it is opens, it will, the reaction will go this side. Okay. And then the pointer should be stood before the venting and also maintain, and the emphasis should be laid on the proper design and maintenance testing of this pressure vessels. So that's why we look called as all the pressure vessels have been inspected by the competent person once in 6 months, if I'm not wrong, internally once in 12 months. Then pressure well should be designed as per the standard, which is IS 2825. So it is very useful standard. You can get this in as an open source. You can search in Google, you'll get this. Tested by the competent person in a solvent vacuum distillation. If the vacuum breaks outside, the air can enter into the make the explosive air mixture in the vessels. This may cause a fire and explosion. To avoid this, the vacuum failures, alarm, and also inert gas purging is necessary. So whenever any leakage happens with this pressure vessel, there is a pressure, the outside air can enter inside and it forms a flammable mixture, resulting a fire or any explosion. So that what we have to do is we should be ready with the purging mechanism so that we can avoid the accidents. On distillation vessels also, alarm and also safety valves are required to indicate any choking or release of the pressure. Sometimes in the distillation columns, choking happens. Choking means obstruction happens in the flow of the material. So in such cases also, we should get the indication about the choking. Then flammable and explosive reactions. So utmost care should be taken during the storage, transportation, handling, and reaction of explosive or flammable materials. And bulk storage of these chemicals come under the purview of chief control of explosives, and free fall of flammable liquids should be avoided, and suitable dip pipes should be provided. Dip pipe is nothing but this already we discussed in static electricity topics. A pipe which is very close to the bottom of the vessel, so that what will happen, the liquid will not be thrown or avoid the free fall of the liquid from the top, so that we can avoid the static electricity. And all the lines carrying the flammable materials must be bonded by the copper clamps and also earthed it. And continuity should be periodically checked, and also resistance to the earth beat shall be less than 1 ohm. And the pumps handling all these chemicals should be a brass and also non-metal impeller to avoid the sparks due to the friction. And flow velocity should be not exceed 6 meters per second in the pipeline to avoid the static charge accumulation. And reaction of flammable chemicals, including solvent distillation, should be carried out at low pressure under vacuum or inert blanketing. Even on distillation vessels, a safety valve or explosion vent should be provided to take care of any accidental pressure or flare, condenser, vent gas condenser, or incinerator should be provided if it is required. So in case of any leakages happens, or if it is in a toxic substance, or we can use scrubbers. If it is a flammable substances, we have to use either a flare or condensator or incinerator, because these flammable gases will not dissolve in water. So those flammable gases must be burned off to make it neutral. Then toxic reactions. So for handling acid or alkali or other toxic chemicals, the workers must be provided with a suitable protective gear, which is nothing but PPEs like PVC or gloves or gumboots, and safety goggles, apron, etc. And the suitable posters showing dangerous the properties of these chemicals, and the safe working procedure should be prominently displayed, and the arrangements for combating spills of these chemicals, such as water shower pipe for uh, covering up, should be available nearby, and also the worker should be trained in these of chemicals safety equipment before giving any responsible job. Inadequately suitable scrubbers, absorbers, and neutralizers for organic gas or inorganic vapors, and the condenser for organic vapors should be provided for well maintained, and also it should be well maintained. Whenever you say flame or explosive mixtures or leakages, there we have incinerators or flares. Whenever you deal about the toxic reactions, where we talk about the scrubbers and absorbers. Now we'll see about the emergency shutdown. We have seen about the various processes and hazards with respect to those processes. Now we'll try to understand the emergency shutdown. In case of any emergency happens, how we can shut down this activity. Because of operational deviations, as discussed above, the other reason of failure of safety and controls device when emergency rises, the situation seems to be out of control, and we should have controls in place. If we see cutting of heat source or starting of the cooling, this is the one of the emergency control. Whenever the reaction went uncontrollable or runaway reaction, there we should able to cut off the heat and start the cooling. Then stoppage of adding new materials and stoppage of mixing. Sometimes the mixing also increases the rate of reaction or increases the temperature, and dilution of internal substances. Then flooding by water if it is ineffective. Then inert gas, which is nothing but N2 purging. Once again. Yes, Suresh, it is an inert gas. Nitrogen is an inert gas. An emergency bypass, transferring the materials and inactivating the catalyst. These are the various shutdown controls should be in place while acting with this kind of processes or operations. And use of vessels and equipments and control room. Many vessels of the equipments are used in chemical process, storage vessels, reactors, distillation vessels, transfer vessels, holding vessels, measuring vessels, open and closed vessels, pipelines variety, etc. We use, and their material and MOC of should be studied. MOC means material of construction, means any equipment the made out of what? For example, some of the metals made out of steel, fiber, or HDPE, or other plastics, etc. So we should understand the MOC should be studied as stated in the safety point of view, and they should be used in enclosed manner as far as possible. And acid alkali solvents and dangerous chemicals should not be handled in open bucket or containers. So these kind of chemicals should be handled in a closed containers because those are toxic in nature. Once it is out, the people will get affected with those gases. Okay. With this, we have done today's topic. So if you have any questions, we can discuss. We'll meet in next class. I've shared all these PPTs, so I'll insist them to share today itself so that you will have a better recap of this session. I think I got an intimation that we have examination notification in October, mostly maybe in another 2-3 classes or maximum 4 classes. We'll complete this 107. Then construction already we covered in IS 103. So it will take maximum 3 to 4 classes. Then we'll start IS 105. Hopefully in August we'll complete our September first week or second week. So we'll have revision and we'll discuss the IMP questions. Any questions? Okay, fine. Thanks for joining. Happy weekend. So we'll meet in next class. Good luck, guys. Bye.